A fitting tribute to the pioneer in experimentations involving electricity would be to recreate Michael Faraday's likeness using 21st century technologies. With the assistance of 3dscanners.co.uk, the UK's most experienced 3D scanning bureau, and Croft Additive Manufacturing, a UK pioneer in metal 3D printing, we demonstrate the processes involved.
What my colleague is doing is 3D laser scanning the artefact provided. What that entails is he just basically runs the equipment which produces a laser line over the part which produces a raw point cloud. Something like this that is quite detailed, you're probably looking at a couple of hours. Something that's less detailed, as in surface features, etc., it can range from 10 minutes up to a full day's worth of scanning. A point cloud is something that the scanning system produces. 9 out of 10 scanning systems will always produce a raw point cloud. It's then what you do with that data in the software to turn it into a 3D measurement, a 3D volume. Hopefully we would have this done within an hour to 2 hours. It shouldn't take that long once the kit's set up and warmed up correctly. You'll then be probably looking to turn it into an STL file with it sort of roughly the same sort of time, probably half a day maximum. When we go to customer sites, it's normally that we scan over a number of products. They can have anything from a full suspension breakdown of a car. It could be lights from the front of the car, aerials from the car, or it could be something as a full car itself.
Basically, we put it onto our system and we opened it up as an STL file at first, and then we put it into the Magic software. The Magic software actually takes the file and slices it in preparation for going onto the metal additive manufacturing machine. The file is transferred, and then the Realizer software gets the file and it takes the slices and gives the instruction to the laser. The first thing that we do is, to set the machine up, we have to put a build plate into the build area. The build plate, when fitted, will be heated to a temperature of 200 degrees C in an atmosphere that has all the oxygen removed and is full of argon. At that point, the machine will lower off the bed and 50 micron of stainless steel powder will be placed on top of the build plate. A scraper blade then comes along and levels that off. The next operation is for the laser to kick in and fire off its first layer's instruction. When that process is finished and the laser stopped, the bed will drop by 50 micron. That means for every millimetre there is 20 layers. The powder is then sprinkled on top and the wipers come and level off that layer. The laser then performs its layer 2 operation, which will melt the powder and attach it to layer 1. The next operation is for the bed to drop, and this process is ongoing until the end of the build. Each layer can take between 30 seconds and 2 minutes, depending on the complexity of what's on the build plate. It's going to take approximately 2 minutes per layer, giving us a total build time of 100 hours. So we have to let it cool down for a short period of time, and then we go in and we vacuum the surplus powder from the build chamber. The build plate is then raised and the rest of the powder is vacuumed. At this point, the powder that's been removed goes through a sieve and is returned to the overhead storage ready for the next build. Handles are fitted to the build plate and it is lifted out of the build chamber.
And here is the finished product. Happy birthday, Mr. Faraday.